Hello and welcome back. Today we will continue our discussion on AC circuit analysis, circuit simplification. Last lecture was about voltage divider and current divider, and today's lecture is about Wye-Delta transformations in order to reduce impedance circuits, similar to how we did with resistive circuits, in order to find voltage, current, or net impedance. Recall that you can either have a delta configuration or a Y configuration, and to convert from delta to Y, we use the following formulas for Z1, Z2, and Z3, and to convert from Y to delta, we use the following formulas for ZA, ZB, and ZC, and that you would superimpose the delta over the Y as shown in this figure here. Example 3, in the following circuit, use delta to Y impedance transformations to find the labeled currents. So the first thing we're going to do is change the delta at the bottom of the network into a Y, where ZA is negative J20 ohms, ZB is 20 plus J60 ohms, and ZC will be equal to 10 ohms. So now using our formulas, Z1 is going to be 20 plus J60 times 10 over 30 plus J40, which is 12 plus J4 ohms. Z2 is going to be 10 times negative J20 over 30 plus J40, which equals 3.2 minus J 2.4 ohms. And Z3 is going to equal 20 plus J60 times negative J20 over 30 plus J40, which equals 8 minus J24 ohms. So next we will redraw the circuit by replacing that bottom delta with a Y. So everything at the top is copied as is, where we label the top node A, the left node B, the right node C, because those node labels still stand. But at the bottom, we now have a Y that will have values of Z1, 12 plus J4, Z2, 3.2 minus J 2.4 ohms, and Z3, 8 minus J24 ohms, and we're going to call the meeting point between those three branches N for node N. So next we're going to simplify our circuit by combining elements in parallel and series so that we can find our voltages and currents. So we're going to have 12 in parallel with 60 at the top of node N, and we're going to have 8 in series with minus J24 ohms at the bottom of node N. After we put 12 and 60 in parallel, we get 18 ohms in series with negative J24 ohms. With this simplified circuit, we can now find I naught. I naught is equal to 120 divided by 18 minus J24. 120 divided by 18 minus J24, which is 4 with an angle of 53 degrees. Next, we will use the current divider to find I1 and I2. And we see that they divide I naught, so I1 is equal to 12 in parallel with 60 divided by 12 times I naught, which is 4 with an angle of 53 degrees. And we get that I1 is equal to 2 plus J 8 over 3 amps. I2 is equal to 12 in parallel with 60 divided by 60 times 4 with an angle of 53 degrees, which is 0.4 plus J, 0.5 amps. VBD is equal to 120 minus negative J4 times I1, which is 109.33 plus J8 ohms. VCD is 120 minus 63.2 plus J 2.4 I2, which equals 96 minus J, 34.65 volts. I5 is equal to VCD divided by negative J20, which equals 1.732 plus J, 4.8 amps. I4 is equal to VBD over 20 plus J60, which equals 0.666 minus J, 1.6 amps. I3 is equal to I1 minus I4, which equals I5 minus I2, which equals 1.332 plus J, 4.3 amps. And this concludes today's lecture on using Wye-Delta transformations to simplify a circuit in order to find voltages and currents. Please come back again.